Okay, now we go into the discussion of standard addition calibration graph. Okay. Okay, for standard addition, what is the meaning? Okay, it means that the sample is added inside the volumetric flask together with the standard. Okay, it means that a portion of sample is added together in the volumetric flask containing the standard solution. Why? Because we want to see how far matrix is interfering our data. As comparison with external calibration method, as I said just now, external calibration method is only applicable if you have 100% clean sample. But if you cannot do any sample preparation to get that kind of cleanliness, you can opt for standard addition, whereby this method take into account how much the matrix gives signal as well. If you are using spectroscopy method, we want to see how much of the matrix absorb or emit the spectroscopy radiation. Okay, when you get signal in standard addition, meaning that the signal is more reliable, means that it is more fair. It is fair and it gives you a data that is supposed to be inside the volumetric flask. Okay, if let's say you have a very dirty sample and then you use external calibration curve, meaning that you are giving signal or data that is not fair, that is bias. That's what we call as bias. Okay, in order to take into account this kind of bias, this kind of matrix interference, standard addition is the best one. Okay, so standard addition method is a solution, is containing solution with matrix interference effect that will give different signal as compared to the external calibration. Okay. Okay. How do we do standard addition method? Okay, let's see. Okay, the same thing. You will have 5 volumetric flasks, same. Okay. You put your unknown solution X over here, inside here, same volume, okay, the same volume. Okay, and then again, compulsory to run blank lah. Blank means that you don't have anything, you don't have any of the analyte or standard solution except for the matrix. Okay, now you put a certain volume or same volume of sample, and then you add your stock solution. Again, we want to add stock solution to make 1 ppm, 2 ppm, 3 ppm, and so on, right? So you put stock solution with increasing volume lah, because you are making concentration higher and higher. So we have 1 ppm, 2, 3, 4, 5 like usual, but this time it's x plus 1, x plus 2, x plus 3, x plus 4, and x plus 5. X represent the sample that you put in the first place. Okay, meaning that in calibration curve, you will not see your intercept nearing 0 at all. If you have X sample, okay, if let's say it contains the analyte that you want, the intercept is not going to be near 0. Okay, means that the intercept will be higher than 0. Okay, so this is the diagram. You see that the the same volume of sample, blue, and then you have the increasing volume of standard solution because the concentration is increasing. Okay, you will have something like this. Okay, oh, by the way, I forgot about another one, which is x plus 0. You have to do x plus 0 as well. Means that ni blank I potong sample. Okay, without any stock solution, means you dilute to the mark as usual lah. Okay, means that there's no stock solution, therefore is x plus 0 ppm. Okay, you see that x plus 0 ppm, it is already colored. So if let's say you are doing dye analysis and so on, you know already that maybe it will contain this analyte X that we want, you see, and the concentration increase as well. So how do we do analysis? You go into the instrument, you inject one by one, and you take all the data, and then you do calibration curve. Okay, and at the calibration, you will see that the concentration 0, 1, 2, 3, 4, 5 as usual, and then signal 1 ppm will give 0 ppm. Okay, 0 x plus 0 ppm will give you some reading. Whenever you see some reading, you know already in my sample I have reading. Okay, and then 1 ppm sini, 2 ppm, 3 ppm, 4 and 5. Okay, so from the YMX plus C, okay, how do we calculate the X? The X from the means the concentration for the from sample X means that Y you are going to set it to 0. Okay, Y0 means it is representing when you extrapolate to the negative side of this x-axis. At this point, this is your concentration. So at this concentration, the Y is 0, right? There's no signal Y. We extrapolate until here. So Y is 0. So it's easy. 0. For example, if let's say your slope is 0.5 plus 1.32, for example. So 0 equals to 0.5 times x plus 0.3. So you rearrange and then you get your x lah. Okay, so this is how we calculate it. You are depending on the YMX plus C once again. Okay, so the question is that which one to use? Okay, in terms of the cleanliness of sample, if it's not clean, standard addition is the best method. However, when you are doing standard addition method, means that it is not usable if you have 100 of samples that are differing in terms of analyte, in terms of matrices and so on. Because why? You did your volumetric solution using sample 1. For example, this sample A. And then you do graph. And then can this graph be used for sample B? Okay? Or C or D and so on. So this is the this is the thing that we have to think about. If you have a lot of samples, I recommend you to work on sample preparation, make it clean so that you can use external calibration curve. But if you only have like 1 or 2 samples and sample preparation cannot do anything much to clean it, then you can use standard addition. For the routine analysis, is usually external calibration curve. Okay, now we already cover on the 2 types of calibration curves. Okay, calibration curve, the first objective is to get to know what is X. How much is X? Okay, how much is X inside the sample? In order to do calibration curve, you have to make sure your instruments are ready, it is accurate, it is precise, and it is robust to be used for any sample. So what should we do? We have to do method validation. Okay, we have at least 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things to do first before you can use this method for analysis. If you are doing standard method, it's easy because standard method is already saying that okay, you should it should get this and this. You should use standard addition method and so on. So when you want to do in your lab, you just confirm by doing several parameters only. But if you are doing published method by somebody else, even though they already validate their method, once you want to use their method in your lab, you have to do this whole method validation parameters. Okay, I will stop my video now because we are going to learn about the meaning of each of these and how to do that by doing active learning on extracting information from FDA Office of Regulatory Affairs Lab Manual. Okay, I checked, it is already updated until June 2020. So FDA documents, you will be referring to this document a lot if you are doing food analysis or any pharmaceuticals analysis related to forensic purposes. Okay, read up. I'm not going to share the PDF because I want you to Google it up. Google this name and then download. Okay, you go straight to page 6 to 7 by the name of quantitative analysis, and 14 to 16 for the glossary. Glossary means that you can know what is the meaning of each of these parameter, and then you go to Kaggle.com, and you start to put your information in terms of mind map. Okay, please add me aemi@utm.my. Okay, you can work in pair. Okay, means that I will only see 3 Kaggle documents. Okay, because you're going to work in pair. Okay, if you don't have any partner, just join another group to be 3 members in the team. Okay, so this is the last video of sample preparation. Okay, it took us 3 weeks. I expect to finish in 2 weeks, but in the end, I add a lot of information that I usually give to my undergrad students, to my final year project student, because I want you to be well versed when you want to do your dissertation as well as working later. Okay, from these 3 weeks of videos and classes, I think it's already enough. And like I said before, if you would like to discuss with me when you want to do your dissertation later, you can always come to me, and I can help you anywhere that I know. Okay, thank you very much, and Assalamualaikum.